So in 6.3, we're going to deal with these things called box and whisker plots. This picture that you see right here is an example of what a box and whisker plot looks like. It is another way to represent data. Just like before we had frequency tables, we had bar graphs or something called a histogram, and we even had those line plots. Now we have another way to look at data. And it's called a box and whisker plot because there's a box and it looks like two whiskers going out from the box on both sides. And what it's going to show you is going to show you a lot of information in a visual format. So let's look at what it's going to show you. The first thing it's going to show you is what the minimum number is. The far left is the minimum. This is going to be your smallest number. I'm going to write that underneath. Smallest number. If that's your minimum and that's your smallest number, then guess what's on the other side? Yes, it is. You were right. It's your maximum. That's the term. It's your largest or your biggest number. And I don't know why I have a smallest number 1 there. I'm just going to put smallest number. There we go. We have our minimum. We have our maximum. We have our smallest number. We have our largest number. Then there's going to be this middle part of the box. The middle part of the box is what we remember that we learned last time in 6.2. That middle part is called the median. It's your middle number in order. Middle number in order. Your middle number, when everything's in order, it's the exact middle number. Sometimes you have to average two numbers if there's an even amount. So we learn, we know what our maximum is, we know what our median is, we know what our minimum is. And it also gives us two other pieces of information that we also have to know. It lets us know this value right here. I'm going to draw an arrow kind of big to the beginning of the box, and that's going to be called Q1 for short. That's our abbreviation. I'm going to say, what's the first quartile? And that's what that is. I'm going to write down that this is first quartile. Q1, let me move that up just a little bit for you. Q1 is our first quartile. It's basically saying this is where the 25% of our data is here and below. 25% of our data is here and below. That's what the first quartile is. Think about a quarter. There's 25% of your data over here. So I want you to put a little 25% right there. If this is our first quartile, if the median is technically our second quartile, then over here at the end of the box, let me draw an arrow, and it's going to be a little curvy one just to get around here. Curvy arrow right there. This is going to be called Q3 for short. That's how we're going to abbreviate it. And Q3 is our third quartile. It's our third quarter of the data. If this is 25% of your data over here, that's 25%, and this is the third quarter, then that means that the box from Q1 to Q3 represents 50% of your data. It's your third quarter. 50% plus the 25% makes a nice 75% of your data. That's what your third quartile represents. It also means that past the third quartile is another 25%, which makes a nice 100% for our graphs. So what you're going to have to do is you are going to have to find all these pieces of information, and you are going to have to figure out what the minimum is, the median is, the maximum is, the first quartile and the third quartile, and you're going to have to make a graph for each one of these things. Before we go and actually do one, I need to write something down about Q1. Okay? So for Q1, I'm going to move this up now. For Q1, what I have down here is cover the median and find the middle of the left side numbers. Cover the median and find the middle of the left side numbers. We're going to write something very similar for Q3 as well. Cover the median and find the middle of the right side of the numbers. Okay, so we wrote down some things. You may be confused still. That's okay. Let's do an example, and the example is I need some real data, but we can make stuff up too if we want to. Okay, I'm going to take a sample from the people who are sitting in front of me. Sorry, I'm ignoring you, but I'm going to pick these people right here. Okay. I'm going to call on you if you're sitting here, and I want you to tell me what your last test score was, and you can lie to me. I don't care. I just need a score between 0 and 100. If you got over, is there anybody who got over 100? I'm not. Lie to me and you lie down to 100, please. Okay? So, Xavier, what'd you get? Just any score?
60.
Perfect. What'd you get?
93.
93. What'd you get?
47.
Thank you. What'd you get?
96.
Okay, thank you.
99.
Thank you. Would you set that right there? Who? One second. Connor, you're next to Tim, right there. Okay, who am I on?
1%.
1%. Okay, I like it. There we go. 100. And last one.
100.
Thank you. Okay. So now what we have is we have a set of data. And what we're going to do is we're going to make a box and whisker plot for these fictitious and some are true numbers. Okay? The first thing that we always do is we put everything in order from smallest to largest. Okay? Put in order. I'm going to put a little star next to this. In order from smallest to largest. Put in order from smallest to largest. Okay. I'm just going to draw a line here so I don't get confused as to where my example begins. All right. So the very first thing I do is, what is my smallest number? I believe it was Connor's number. Then what's the next number? And to stay organized, I cross them off once I find them. What's the next smallest number? And what's the next smallest number? Close. 93. Then the next smallest number? And the next smallest number? And then our last two numbers, it doesn't matter which one goes first, which one goes second, because 100 and 100 are the same size. Okie dokie. So now you have everything in order. You can right now figure out what your minimum is. Which number is your smallest number? So I put min right here. This is your min. You can figure out what your largest number is. What's your max? What's your max?
100.
Thank you. So this is exactly how we do it. The first thing we do is we put it in order from smallest to largest. Then the second thing we do, so I'm going to put a number 1 next to that. The second thing we do is we identified min and max. Min and max. That's the second thing that I just did. I have to put that off to the side because I don't have enough room for that anywhere else. Identify your minimum and your maximum. The third thing we're going to figure out is our median. And our median is our middle number. So if I want to find our median, then what I like to do is I like to say, okay, one number, two numbers, two numbers, three numbers, three numbers, four numbers. I need to know what the median is, and it's right here in between these two things. That's what my median needs to be. Now, there isn't an even number there, is there? So, how do I find the median between 93 and 96? My median. I have to find the average of the 93 and the 96. How do you find the average of 93 and 96? What if it's a decimal? That's okay. So what is my median? My median is 94.5. And if you need to, I'm going to write here, it was 93 plus 96 divided by 2. If you want to know how I got that, that's what I just did on the calculator. 93 plus 96 divided by 2. So now I have my min. Now I have my max, and I have my median. I have 3 out of the 5 things I need for my box and whisker plot. I have the min, I have the max, I have the median. So then the next thing I need to figure out is what is Q1 and what is Q3. If you don't know how to find those, that's why we wrote this stuff down. Cover the median and find the middle of the left side numbers. So let's figure out what that means. Here's my median. Let me put this back so you can see it. I cover up the median. Here's the median right there. I'm covering it up with my finger. Covered it up. Because the median's in the middle, right? Right here. Let me just draw a little line. I cover it up. On the left side, I need to find the middle number of the left side. It's, okay, how many numbers do I have? The 93, the 60. I have the 1 and the 47. What's the middle number here between these two things? This is Q1. How are you going to find Q1? You're going to add 47 and 60 together, and you're going to divide by 2. If you don't have that, you can use a calculator for that, of course. 47 plus 60 divided by 2. And we'll switch it to a decimal. I'm getting that is 53.5. That's our first quartile. Sounds so official when we say quartile. If that's how we found the first quartile, do you know how you're going to find the third quartile? Let me read you what we wrote. Cover the median. Cover the median and find the middle of the right side numbers. So I need the exact middle between these two things. That's our Q3. Now I know exactly the middle of 99 and 100. It's 99 plus 100 divided by 2 if you wanted the math behind it. But I actually know what that is. Think of the number that's exactly in between 99 and 100. That is 99.5 is Q3. And so now you have every piece of information you need for a box and whisker plot. And I need you to do something that makes a whole lot of sense. Okay, so wait, I know what I forgot to write down. Over here, we wrote, second we found min and max. The third we found the median. The fourth, find Q1 and Q3. That was the next thing we did. Plot, last step, plot the box and whisker. Now we got to actually make a graph with this. The hard part is making sure we're counting by the same intervals. So here's how we make the box and whisker. We have to go from 1 all the way to 100. So what I'm going to do is I'm going to make a number here. I'm going to start with 0. And I'm going to go to 100. So I have 0 and I have 100. And I got to think, I got to divide this up into equal pieces. 10. So let's see. 50 is going to be here. I might as well go 25 here. 0, 25, 50, 75. Okay. See how these are in equal pieces? I want you to have yours with equal pieces. You can count by 10s, you can count by 20s, you can count by 25s, whatever makes it nice and easy for you. Where's our minimum at? What's our minimum? You can thank Connor for this. Thank you, Connor. What's our maximum? And these are our ends of our whiskers. These are those big dots. They signify this is your minimum, this is your maximum. Where is Q1 at? What's our number for Q1? $53.5. So here's 50. 53.5 is going to be a little bit past, and I make a a left side of a box. This is the left side of my box. This is my first quartile. Where's my median at? Remember that number we found? Where is 94.5? It's not at 100. Here's 75, so that's 80. 94 is probably right here. Is probably where my median's at. Where's Q3 at? Almost at 100, but not quite, right? There's got to be really, really close. And so I have everything I need for my box and whisker plot. I have my box and I have my two whiskers. This lets you know that the minimum's around 1. Your first quartile's around 53. Your median is around 94 and a half. This Q3 is 99.5, and then over here is your maximum. So there you go. This is a box and whisker plot. You're going to be asked to do that on the first 3 problems. How to make a box and whisker plot is what you're going to have to do. There's a few things that we need to talk about. I need to define a few more things, and then we'll rock and roll. Let's talk about an IQR. Then we'll have to flip this page over. IQR. If ever I ask you to find the IQR, this is called the interquartile range. There's a formula for IQR. It is third quartile minus the first quartile. Q3 minus Q1. Basically, I'm saying, what's the third quartile subtracted by the first quartile? How far apart is that interquartile range? If I want to know what the IQR of our previous example was, I would take 99.5 and I would subtract 53.5. The IQR of this example is 99.5 minus 53.5, and you figure out what that is. I do recommend you use a calculator. And I'm getting 46. Over. We got to put some more notes on the back side. I got 2 more things to tell you about. 2 more things and we'll be done. But there's only 1 section today, so that's a good thing, right? I know the notes are a little bit longer today. I'm sorry. Outlier. How can you tell if something is an outlier? An outlier is more than 1.5 times away from the box. Thank you. An outlier is more than 1.5 times away from the box. Like, how are you supposed to know if something is an outlier? It's really far away from the other pieces of information. But visually, you can tell. I want to show you. Remember how Connor told us that he had a 1% on the last test? He's here. Is he more than 1.5 times away from the box? Let's look at this. Like if I were to take my ruler and I see this and I go, it's from here to here, is it more than 1.5 away from the box? He is not an outlier technically by definition. It looks like one, but it's not, because we had two other scores that weren't too far away from him. Okay? Don't just assume everything's an outlier without checking. It has to be 1.5 times away from the box. That box distance and a half of a box distance is how you can tell. If these two scores were slightly higher towards the 90s or the 80s or 70s, I think we would have had him as an outlier. The box was just too far apart. Okay. By the way, what happens with outliers? I want to put down here. Outliers thank you for letting me know that. Outliers have the biggest effect on the mean. Zoom out. Skosh. If there is an outlier, it messes up the average. If I were to try to figure out what the average was on those scores that this column of kids gave me, then Connors would have lowered the average quite a bit. It has the least effect on the median, by the way, just so you're, bless you. I wrote down here, if you have an outlier, use the median as the best way to describe the data. The last thing that we need to talk about is something called percentile rank. Percentile rank. Your percentile rank, the definition of it, it's the percentage of data values that are less than or equal to that value. I'm going to give you an example of percentile rank. Number 12. I'm going to write down the problem. I'm not going to write down the whole problem. I'm going to give you a summary. There's 25 dogs. 15 weigh more than 35 pounds. What is a dog? What percentile rank? What percentile rank? What percentile rank is a dog that weighs 35 pounds? There's 25 dogs. 15 dogs weigh more than 35 pounds. What percentile rank is a dog that weighs 35 pounds? Ray, let's find out if you're right. Not sure if you're right yet. 60? Okay, let's see if he's right. What you're going to have to do with percentile rank is you're going to have to figure out is the percentage of data, the values that are less than or equal to that value. How many dogs are less than or equal to 35 pounds? How many dogs are less than 35 or equal to 35 pounds? There's 25 dogs. 15 weigh more than 35 pounds. How many weigh less than or equal to 35 pounds? Okay, so that's the number that goes on top. So Ray was not right. It's okay. Don't worry. That's why we are learning. This is what the class is about. It's learning. Sometimes we make mistakes. Don't forget what the definition says. It's who are less than or equal to that value. There are 10 that weigh less than 35 pounds, and we divide it by how many dogs do we have? Okay, so I'm going to write something down that helps me. I'm writing 10 weigh less than or equal to 35 pounds, and I'm dividing it by how many dogs. That's what you're doing. And then what you're going to do is you're going to convert this to a percent. You're going to change it to a decimal. Which is 0.4 equals 0.4. But what is that as a percent? You then have to move it 2 places to the right, and you get that it is 40%. The dog that weighs 35 pounds is the 40th percentile of those dogs that were in this particular survey. Does that make sense? Sometimes it's going to be directly like what Ray was thinking, where you're going to take the 15 and divide it by 25. But in this case, you actually had to do one step before you could figure out what the percent is. We're going to stop your notes right there.